In this video, we're going to be looking at inverse sine functions. So if you look at our sine function, it's not one-to-one. If we were to do a horizontal line test, you would see it hits more than once. In fact, just in this little window, it's already hit twice, making it not one-to-one. However, if we take and just make this little window and do a little crop and paste, and we cut these off right here and these little tails off, now within that window, right, we have a one-to-one function. You can see that it passes the horizontal line test, it passes the vertical line test. And so what we say is we have y equals sine to x, it's a one-to-one, on this domain. And so we can cut it from negative pi over 2 to pi over 2. That is now a one-to-one function. Now we might as well have the range too, and so that goes from negative 1 to 1. So now that we have our function, we know it's one-to-one, we have our domain and our range, we now know that this is our inverse, and that's its domain and its range because it's the inverse. Remember, the x's and the y switch, the domains and the range switch. But what that means now is these are the only two regions that we can use on our unit circle, not these. So if there's a positive value in an inverse sine, right, we're going to be getting these angles. So remember, inverse sines are reverse. So you can see that their inputs now are the ratios and the outputs are the angles. So these are the inputs here of our sine. So the y coordinates, let's circle them now. These right here are all, oops, I missed that little guy right there. I'm going to have to do it all over again. All the y coordinates are our inputs. So let's try some to get an idea of what's going on. So we have some rules here, and I'll explain these when we're done, okay? So the first one, we're going to find the inverse sine of a half. So you can see now we're plugging in the ratio. So we go back up here, and we can only look at these, only from negative pi over 2 to pi over 2. There is a half, and so a half gives us pi over 6. So the answer is, let's put this in blue, pi over 6, or you can do 30 degrees. It's your choice. So now if we look at negative rad 3 over 2, that's right here, so that would give us 5 pi over 3, or 300 degrees. And now if we look for sine of 2, do you see a 2 there? No, we know it goes from negative 1 to 1. That 2 is outside of our domain. So if it's outside of our domain, this is not possible. So it does not exist. And you could test this in your calculator. If we input sine, and you'll see the inverse is right above. Remember, all the inverses are above in blue. So inverse sine of x, oops, of 2. And now what happens here on this is we are inputting a ratio, and that ratio is becoming an angle, and then it will come out sine. So let's see what happens. There you go. See, it doesn't work because of the 2. All right. Now what about if we plug in pi? Well, pi is being plugged into sine. We got to be careful there. So pi going into sine is over here, and that's fine. This is a one-to-one sine. This is the inverse. So this is the reason these are affected. So if you're dealing with inverse, then you have to look at this stuff. But with sine, sine's domain is all real numbers. So we can plug pi into sine. If we plug pi into sine, you get 0. So we already knew that. Those don't change. Whatever it was before, it is. So sine of pi is 0. So we just replace it. Now, here's where it comes into play. We're now dealing with the inverse. The inverse, we now have to narrow our focus to here. This is the only place we can look when we're dealing with an inverse. So if we're going to plug in 0 into our inverse, then we look at our little y coordinates, and it says it's there, so the answer is 0. So you can see, even though we started with pi, it was modified into 0 at the very, very end. And you can check this in your calculator, and you see there you have it. So sine of pi came out to be 0, and the inverse sine of 0 is 0. So let's try it again. Sine of pi over 3. Well, pi over 3, we're good. So sine of pi over 3 is here. So sine of pi over 3 would be rad 3 over 2. So that's radical 3 over 2. Inverse sine. And then we look in the exact same location. So think about it. This is sine pi over 3, we get rad 3 over 2. Well, inverse sine of rad 3 over 2, that's pi over 3. It just goes right back. And that takes us to our rules here. So if we're going to be plugging a number in from negative pi over 2 to pi over 2, then that means we're dealing with these regions. And so the inverse and sine are just going to switch coordinates, right? You can just kind of think about it. These are your x's, these are your y's, these are your x's, these are your y's. So the x for the sine is pi over 4. The y for the sine, the y for the sine is rad 3 over 2. And then for the inverse, it's rad 2 over 2 and pi over 4. They just match. So all we're really doing is saying, okay, well, we got pi over 4, comma, rad 2 over 2. This is for sine. So for the inverse sine, it's just going to be rad 2 over 2, comma, pi over 4. So if I plug pi over 4 into sine, it's going to give me rad 2 over 2. Now if I plug rad 2 over 2 into inverse sine, it's going to take me right back to pi over 4. So that's what this is saying. They just counteract each other. This is going to spit out the y. We plug the y in, it spits out the x. So it works perfectly. But it has to be between negative pi over 2 and 2. This one wasn't, and so what it does is it takes that pi and reverts it back to something in between them. All right, so we can look at this one, and it works the same way. Is 1/2 between negative 1 and 1? Yes, it's within the region. So we're going to end up with is our x, which is 1/2. So it works the same idea. If we come up here to 1/2 is pi over 6. So we have pi over 6, comma, 1/2 for y equals sine x. And y equals inverse sine of x would be 1/2, comma, pi over 6. So if we come down here and look at this the way it is, so we're plugging 1/2 into inverse sine, which is pi over 6, and then we plug the pi over 6 into sine, it takes us right back to 1/2. So that's all this is saying. To cancel each other as long as you treat them within their proper domains. So if you keep the sine x in its proper domain, it's going to just revert it right back to x. And if you keep this x within the inverse's domain, it's going to spit it right back to its original x. And there you have it.